My name is Hemant Khurana and I am a student of class 10th B, and today in this video I am going to show you the difference between parallel arrangement and series arrangement of resistors. So let's dive into it. My basic idea was first to just use an ohm meter, but my multimeter seems to be dead because it has no battery. So I prefer to use a microprocessor, which is basically a type of a chip which automates everything in a circuit. Like if I want to turn on and off a LED bulb 5 times in a second, so I will just click the LED bulb switch 5 times, or instead of clicking it 5 times, I'll just add a microprocessor which will do the same for me. So let's just code it and assemble it and let's see what we got. After getting the idea of microprocessor, I was thinking how I am going to arrange the resistors. So let's see how I arrange the resistors and how I soldered them. So as you can see, I am back on my soldering desk. So I have 4 components here. This is the 220k resistor, and this is the 10k resistor, and this is the series arrangement. So these 3 resistors are 10k. So according to the calculations, 10k plus 10k plus 10k, which will be equal to the 30k ohms resistance. So let's see the readings. And this these are 220k resistors connected in parallel. So 1 upon 220k plus 1 upon 220k plus 1 upon 220k will be equal to around 75 kilo ohms. So let's see. As you saw the resistors, now let's have a glimpse of my final circuit board. After the circuit board, let's move on to the readings. So let's see. The current readings are 0. That is because no resistor is connected. So let's connect a resistor of 10 kilo ohms and check the readings. So the reading should be around 10,000 because 1 kilo ohm is equal to 1000 ohms. So 10 ohms will be 10,000 ohms. So let's see. Okay, as you can see, the readings are around 10,000. So, which means our ohm meter is totally correct. So, let's now connect a resistor of 220 kilo ohms. So, the readings should be around 2,20,000. So as you can see, I have now successfully connected the resistor and the readings are almost around 2,20,000. So now let's start performing our activity by connecting the 2 arrangements. So as we predicted in the calculations, the resistance of the series arrangement should be 30 kilo ohms, which is equal to 30,000. So let's see. So the readings are almost 30,000. So our calculations are totally right. So now let's try to connect the parallel series. This is the parallel arrangement. As you can see, 3 resistors are connected in parallel. So now let's connect it in the circuit. So as we predicted, the readings are almost around 74,000. So as we saw that readings were totally same as the calculations, we can conclude that parallel arrangement is measured as the sum of the reciprocal of the resistor's resistance, and the series arrangement is measured as the sum of the resistor's resistance. Now let's connect the 220 kilo ohm resistor arrangement, which is in parallel, to the 10 kilo ohms resistor in series and see what readings we get. So as you can see, the current readings are 0. So now let's connect the series and the parallel arrangement combination to the circuit. As you can see, I have successfully connected the resistor to the circuit and the current readings are around 85, with which we conclude that our calculations were absolutely right. Thanks for watching the video. This was the proof that the parallel arrangement and the series arrangement are both different and are calculated differently. Thank you.